Let's jump right into this explainer. Today, we're embarking on a real mathematical detective story to solve one of the deepest, most stubborn mysteries of the universe, the Yang-Mills existence and mass gap. If you've ever wondered how the chaotic macroscopic universe we live in is fundamentally anchored by rigid, microscopic mathematics, you are in the exact right place. We're going to unpack a radical new framework that translates four-dimensional gauge theory into a global geometric stabilization problem, cracking a puzzle that has literally stumped physicists for decades.
Here's our roadmap for today. We'll start with the unsolved physics mystery, build out the Adelic number framework, unpack the equations of existence, derive the mass gap, map out the glueball spectrum, and wrap up by simulating the proof. Let's get to it.
Section 1. The unsolved physics mystery.
We're starting with a problem so massive it comes with a Millennium Prize bounty from the Clay Mathematics Institute. It's a dual challenge. First up is existence. We have to mathematically prove that for any compact simple gauge group G, a quantum Yang-Mills theory unconditionally exists on continuous four-dimensional space. The second part is the mass gap itself. We have to prove that the lowest energy excitation above the vacuum, represented by the delta symbol, is strictly greater than zero. Absolutely no massless gauge excitations are allowed.
So what does this actually mean operationally? Well, the mass gap essentially means the universe flat out refuses to allow these specific particles, glueballs, to exist without a baseline non-zero mass. They are fundamentally restricted from having zero energy. Think about it. If this gap didn't exist, the fundamental forces holding our reality together would just unravel. But the massive headache for physicists is figuring out how to prove that mathematically, especially when traditional continuous space theoretically allows for infinitely small energy states.
Section 2. The Adelic number framework.
To solve this, we're bringing in a totally unexpected mathematical tool. You see, traditional quantum field theory struggles over infinite continuous real space because it allows arbitrarily high divergent energy fluctuations. Those are your classic ultraviolet divergences. To bypass this entirely, the Adelic Langlands Program splits reality into two distinct regimes. On one side, the Archimedean frontier, where we have the continuous real gauge group governing smooth macroscopic physics. On the other side, we embed the gauge group into local non-Archimedean p-adic gauge groups. This represents the microscopic ultraviolet core.
The magic happens when we compare these two environments. You can think of this p-adic regime as an exact natural arithmetic lattice. Because p-adic numbers are totally disconnected and fractal, their local packing fractions act exactly like a mathematical cooling sieve. They structurally forbid those wild, infinite, continuous energy concentrations that completely plague traditional physics. We're essentially using rigid arithmetic to tame continuous infinities.
Section 3. Equations of existence.
All right, let's really look at the math here, because the quantum J-flow equation is the literal engine of this existence proof. Tracking the change over time, the partial derivative of omega, we can observe the automorphic data stream. This mathematical representation is strictly constrained by Ramanujan-Pedersen bounds, which means the curvature elements of this equation can never diverge. This flow smoothly converges to a unique, non-singular critical metric form, omega infinity. It's this smooth convergence that mathematically proves the unconditional existence of the regularized quantum field theory.
And the mathematical hero making that convergence possible? That's the quantum parabolic slope criterion. In plain English, this criterion is a topological guardrail. It keeps our mathematical engine from crashing into infinities or hitting destabilizing walls. It ensures the data stream remains confined, smooth, and entirely solvable from start to finish.
Section 4. Deriving the mass gap.
Now we track how this stabilization physically forces our mass gap to emerge. The global Adelic Laplacian, which is the mathematical operator measuring energy, is forced by this inequality to be strictly greater than the arithmetic conductor times the identity matrix. Because the data scatters at finite primes, the math physically forces a positive lower bound, leaving behind a pristine energy deficit. When pushed into continuous space, our delta equals the effective Planck constant times the square root of that conductor. The spectrum is structurally mathematically forbidden from ever approaching zero continuously.
To see exactly how that structural protection works in practice, we use the Seiberg-Witten geometry alignment. This unified framework beautifully translates standard continuous gauge theory directly into discrete arithmetic algebraic geometry.
Think of this as our translation dictionary, mapping the continuous directly against the discrete. The Seiberg-Witten curve aligns perfectly with the arithmetic modular curve. The differential maps right to the holomorphic cusp form. S-duality space is governed by Hecke algebra operators. And my favorite part, continuous topological obstructions in spacetime are completely determined by discrete modular Fourier coefficients. The continuous is entirely anchored by the discrete.
Section 5. The glue ball spectrum.
It's time to translate this abstract mathematics into observable physical evidence, specifically the masses of real-world glue balls. Here, the Virasoro character formula acts as our generator. By computing this infinite product explicitly for the SU3 strong interaction gauge group, we can take a Taylor expansion to reveal the exact physical mass steps. It tracks states as they decompress into continuous space, all anchored by that mass gap delta. We're essentially decoding a cipher to find out exactly what physical states the universe actually permits.
Let's break down those steps, because the coefficients of our expansion tell us the whole story. Q to the 0 equals 1. That's our unique vacuum ground state. But the absolute smoking gun of the entire proof is step 1. Q to the 1 equals 0. There are 0 states at the first excitation level. This is it, the explicit physical manifestation that massless gauge excitations are unconditionally forbidden. The mass gap is confirmed. From there, we jump to mass level 2, generating a single tensor glue ball, level 3 gives an odd spin glue ball, and so on.
Section 6. Simulating the proof. Finally, let's look at the numerical simulation that proves the math definitively holds up. By tracking the spectral gap magnitude against the spatial scale parameter, we can see what happens as we approach the continuous boundary. As epsilon approaches 0, watch how the data absolutely refuses to drop to 0. Instead, it hits a rigid, non-vanishing plateau. That finite prime lattice is acting as our cooling sieve, regularizing the continuous space. Notice too that as we increase the complexity of the finite primes from 3 to 15, that baseline plateau actually elevates. The gap is mathematically locked above 0.
Taking it one step further, we can inject actual modular curve Fourier coefficients into our tracking framework. Even when we introduce complex Fourier phase data mimicking physical turbulence, the Ramanujan shield guarantees that the operator modifier remains strictly positive. The local spectral components are utterly forbidden from vanishing. The absolute positive floor of the mass gap is completely unconditionally protected by the arithmetic bounds.
I want to leave you with this profound realization straight from our source material. The very mass that grounds our reality isn't just some physical accident. It is a direct, calculated result of rigid quantum lattices anchoring continuous spacetime. The continuous parameters of the universe are fundamentally stabilized by discrete numbers. If the literal fabric of reality is woven from arithmetic, well, what other physical mysteries might just be prime numbers hiding in plain sight? Thank you for exploring this amazing framework with me today.